So before we get into a practice problem, I just want to briefly review the law of sines. So given a triangle with angles ABC and, corresponding sides ABC, remember, notice, side A is across from angle A, side B is across from angle B, and side C is across from angle C, or as it says here, faces the angle. So keep that in mind because that's really, really important when we're plugging into our equation. Remember, we can either just look at these two, we can look at these two, or we can have, A over sine A equal to C over sine C. So we're never going to use all three at once. We kind of have to pick and choose when we want to, which one would be most beneficial. Okay, speaking of picking and choosing, while law of sines helps us solve non-right triangles, it doesn't always work. It's not like any non-right triangle you're given, you're just going to be able to use law of sines, right? The times we can use it is when we know at least two angles and a side. So I like to refer to that as angle, angle, side. Or when we know two sides and the non-enclosed angle. So that's going to be side, side, angle, or angle, side, side, right? So, angle, angle, side would just be if we had, we know this angle, and we know a side, right? It doesn't matter which two angles we know, because remember, if we know two angles of a triangle, we know all of the angles, because all three angles of a triangle always add up to 180. So if you know two, you can always solve for the third. Okay, and then side-side angle would be when you know a side, and then one of these two angles, right? So if we know this side and this side, we've got to know one of those two angles. Okay, the important thing is that it's not, if we know this side and this side, this right here is the enclosed angle because it's the angle made by those two sides. So as long as we either know this one or this one, that would be side-side angle. Okay, so those are the two cases where we can use the law of sines. So the first example I'll do is we have two sides of an angle opposite. One of those sides is known and you are trying to find the other angles. So we'll just solve for x here. Notice we've got this side and this side. You can't tell what I'm pointing to, but we've got two sides in an angle, and it's a non-enclosed angle, right? This goes side, side, angle, which is why we can use law of sines here, right? You don't know law of cosines yet, but if we had known this angle instead, so the angle enclosed by the two sides, this would have to be a law of cosines problem. But because we got side, side, angle, we can use law of sines. Now, I'm going to go ahead and label this triangle because that helps me figure out how to set up my formula. You don't have to. You can label in any way. I'm just randomly putting A, B, and C in places, which would make this side A, this side B, and this side A. So what it looks like to me, it looks like I have side B and angle B. Oops, I called this one C, or A. That's why I was being confused. This is how they should be labeled. So notice I'm looking for angle C. I have side C. I have angle B and side B. So when I'm looking at my formula to try and decide what I could use, well, I'm looking for angle C. So I've got to include, this part. I've got to include C over sine C because I need the variable I'm looking for to be part of my equation. Well, then I need to pick, am I going to use A over sine A or B over sine B to finish out my proportion? And in this one, I'm going to use B over sine B because I have a piece or both pieces of B. I don't have any of the A things, so that doesn't help me anywhere. So the equation we're going to use here is going to be B over sine B equals C over sine C. Right, and remember what goes into a trig function is the angle. So it's always the angle going into the trig function. So the way that this would work here for this equation would be 49 over sine of 115 equals C, which we actually have that, 16 over sine of C. Now notice, The only thing we're missing here is angle C. We have an equation with one unknown, and that's the way we want it to be able to actually solve for this. So this is all good. Now, before we solve this, I want you to think, 49 over sine of 115. Even though it's got a trig function in there, that's actually just a number, right? Kind of like back when we did logs, where, log of 5, it's just a number. We can treat it like a number. However, we're not going to calculate out what 49 over sine of 15 is, because we would have to round, because it's going to be a decimal. So we actually don't solve anything out until the very end of the problem. So we're always first going to algebraically solve, and then secondly, type it into our calculator. So here we go. I'm looking to isolate, and I've changed it to x, but we called it angle C, so C or x will work here. I'm looking to solve for that. So I can't actually do that until I use inverse trig, which we've used in geometry, but maybe we haven't used it since then. But before I can do that, I need to get sine of x by itself. So my first goal is to get sine of x just at least on one side of the equation by itself. Now, the way I'm going to be able to do that is by cross multiplying. So what that's going to look like, if you don't know what that is I kind of multiply in an x in a cross over the equal sign. So that's going to give me 49 sine of x equals 16 times sine of 115. Now, just like with square roots and natural logs and all of that, sine is a trig function. We can't multiply into it, right? We can't make it, this is a big no-no, right? Sine of 115 is a number in itself. That number is then being multiplied by 16. Okay, so that's the first thing to clarify. Okay, and why does cross multiplying work? Well, we can think of cross multiplying as multiplying both sides by sine of x. So we multiply both sides by sine of x, and notice, it cancels on this side, and we're just left with 16. And then we would multiply both sides by sine of 115, and that would cancel on this side. So that would leave us with 49 sine of x equals 16 sine of 115. So the logic behind cross multiplying is really just multiplying both sides by the opposite denominator to eliminate them. So now once we have this, the next step we'll take to isolate sine of x is dividing both sides by 49, right? It'll cancel over here, and you'll have that. Okay, so now we've got to get that angle out of the sine function. So now we've got to use an identity that you should hopefully remember a little bit from Algebra 2. And it's the fact that if you take a function and compose it with the function's inverse, you're just left with the input. And what I mean by that is if we have f of x and f inverse of x, and these two functions are inverses of each other, f inverse of f of x equals x. So if you compose a function with its inverse, right, this is right here is composition of functions, you're just left with the input variable, which in this case was x. So I'm going to use that same idea on sine, and I can use the fact that I know inverse sine and take the inverse sine of both sides, because remember, whatever I do to one side, I must do to the other, but that will leave me with just the input variable. So let's see how this looks. All right, so now you can see that I've taken sine inverse of both sides. Because again, whatever I do to one side, I have to do to the other side. And now what we'll see happen is, because sine inverse and sine are inverses of each other, sine inverse of sine of x is just going to leave us with x. Okay, so on this side we'll be left with x, and then on this side we're left with something that it looks not cute and a little bit algebraically rough, but actually this all simplifies to just a number. This now is a calculator problem. We just have to input this into our calculator. But I really, really strongly urge you to practice this, because even if you can get this far on a test, that's great, but you've got to be able to punch it into your calculator properly. So I'm going to go ahead and do that, and I'll kind of then write out how you need to do that. Okay, and that should give you 17.213746, ... We're going to get in the habit of rounding to the nearest hundredth, so 17.21 degrees is the value of angle C or angle X. Now, if you have a calculator similar to the calculator that we use in school, what you're going to want to type in and the order you're going to want to do it is you're going to hit second, then sine, and it will put sine inverse for you. So second sine will give you sine inverse, and it will start with a parenthesis. Then you'll hit 1, then 6, then the multiplication symbol. Then you'll just hit the normal sign. Then you'll type in 115. Important thing, close that parenthesis sign so we know that only sine is only 115 degrees is inside the sign. And then hit the division symbol, and then 4, 9, close parentheses again. That's closing the beginning parenthesis that was open for you on the sine inverse. And then you just hit, I guess I should add that, you hit the equal sign and you should get 17.21. Okay, and the way this is going to look in your calculator, so I will write that out, is in your calculator, it'll look as sine inverse 16 times sine 115 divided by 49, close parentheses. Okay, so this is the buttons you click, and then this is what it needs to look like. So really not, that intense of a look, and that should give you 17.21 degrees. Okay, and we have now solved for this angle. And I guess the question technically wanted us to find all of the other angles. So if we know this is 17 point, not 117, that would not make sense. If we know this is 17.21 and this angle B is 115, we could find angle A by simply doing 180 minus 115 minus 17.21. And that's going to give us that this angle is 47.79 degrees. Alright, so for this one, we've got two angles and one side, and we're going to try and find the missing sides, or in this case, again, we're just going to look for X here. So this would be a case where we have angle, side. So first thing I'm going to do again is label the sides and angles, according to A, B, and C, so that I can figure out, how I'm going to use this formula. So if I call this A, this is side A. If I call this B, this is then side B. And if I call this angle C, we'll try and make that look like a capital C, then this is side C. So we're looking for side B. So since we're looking for side B, we're clearly going to have to use this part of the formula, right? We've got to include the thing we're missing in the formula, okay? So we have to have side B in there. And then we want to look at what do we have a matching pair of information with? Do we have both angle A and side A, or both angle C and side C? Because we need a pair of information to be able to have, one unknown. And if you look at this, we have got both side C and angle C, right? For A, we don't know what side A is. So throwing A over sine A into the equation, it's not going to be something we're able to solve because we don't actually have enough information there. So I'm going to use side C over sine C. Okay? Side C. Sorry, that's probably confusing. side with a DC over sine, like, the trig function of C. And you can see it right there. So then what I'll go ahead and do is fill in what I know. So I've got side B is what I'm looking for over sine of, and here's a problem, I don't know what angle B is, and I need it for my formula, right? I can't just switch over to a different, piece of the formula, because I've got to have that little b in there. And then that's equal to 15 over sine of 22 degrees. So how can we find angle B, right? It has to be able to work because we've got angle side, and that's, supposed to be allowed for law of sines. Well, what we have to do is we're given two of the angles, and we know that all angles add up to 180 degrees. So we can find angle B by doing 180 minus 22 minus 48, which is going to give us 110 degrees for angle B. So I can go ahead and throw that into the equation. Now I can solve for B. Now, the last one like this we solved by cross multiplication, but we don't actually have to use cross multiplication here because we're solving for B, and the only thing happening to B is that it's being divided by sine of 110. So we can undo dividing of sine 110 by just multiplying both sides by sine of 110 degrees. So notice on the left-hand side of the equation, sine of 110 degrees will cancel, and that will just leave us with B. Now we have 15 times sine of 110 degrees all over sine of 22 degrees. And at this point, this is now a calculator problem. We just plug this into our calculator and it will tell us the length of side B. So I'm going to verbally say how we type this one in. So you're just going to hit 15 sine 110 close parenthesis, right? It's really, really important that we close the parenthesis around sine in our calculator so that it only takes the sine of 110. It doesn't try and take the sine of the sine. Then divided by sine of 22, again, close the parenthesis, hit enter, and we will get that this side B, or, X, which is what we called it, is 37.62717, and we're going to round to the nearest hundredth again. So side B is 37.63, and we don't have any units to put on it because they didn't give us units, right? Remember, this is a side length. We don't know if it's units, meters, inches, whatever. So we'll just leave it as 37.63.